Hey, well here we are in possibly the last video, depending on what order you watch things in, or you might be looking at the exam video, and of course you'll go back and look at all the old videos. But this is normally the one that I do in the last lecture, if we were doing things live. So basically it's just having a look back over the course, seeing what we tried to achieve, what we tried to teach you, and then how we're going to assess whether we think you've learned it. Right, so we started out talking about data modeling, turning ER data models into relational schemas, then writing SQL using stored procedures, i.e. PLPGSQL, and writing triggers and writing aggregates to give Postgres more capabilities. And then when you need to write applications, you need to write scripts in a programming language. We wrote them in Python with the so-called PG2 database connector. We had a brief look at how relational database systems work and how you can examine what they're doing using the explain command. And finally, we had a very quick look at transactions and serializability. Alright, so the syllabus, and this is pretty much the order I would teach it if we didn't have to front load for the more practical stuff. So data modeling and database design, notice that we talk about relational theory early on because it's related to building relational data models and checking whether they're in normal form. And also we would have talked about relational algebra early on because you can use that as a background for then talking about SQL. But on the other hand, you can just launch straight into SQL, which is what we did, and then we came back and looked at relational algebra. So writing queries, writing fairly complex SQL queries, and then extending the capabilities by writing views and functions and aggregates and triggers, using PostgreSQL in more detail. We had a brief look at SQLite 3, which has an SQL dialect which is similar to Postgres, but a lot of other things about SQLite are quite different, and I'm pretty sure that you can't do any of those things in SQLite. Then we looked at Python and PG2, and finally we had a very brief look at aspects of database theory, and here I've doubled up with relational algebra, which probably more naturally fits early on, and similarly, in fact, all of those aspects probably would have been done earlier on in the ideal world. Then talk a little bit about DBMS architecture, and finally a very little bit about indexes and how to use them. Alright, obviously this is a course, so you have to be assessed so that I can work out how much you actually learned. And this is copy-pasted straight from the course outline, so hopefully it's fully correct. So 18 marks for the quizzes. I'm going to take the best 7 quiz marks. Each quiz is worth 4 marks. That'll add up to 28. And then convert a mark out of 28 into a mark out of 18 by a little bit of SMS magic. And then the various assignments, assignment 3, you've probably finished quite recently. And then of course you're doing the exam, and that's out of 40. Normally I'd make it out of 100, but in these days of COVID, we have to put more weight on these other aspects. So you need to get a decent mark in the exam. You can see 18 out of 40, that's not quite a pass, but you have to get close to a pass. And then we add everything up. If your exam wasn't close enough to a pass, then you end up with a UF grade, which is a fail, regardless of the overall mark. If your mark is less than 50, then you get a fail. And finally, if your mark is greater than or equal to 50 and your exam was okay, then you get one of the regular grades. So hopefully that's clear enough. A few people have been asking about marks. My plan is to ensure that all of these are available by Monday, 30th of November, which is a couple of days before the exam, so you'll have a fair idea where you stand. And if you've already got 60, well, you can't bludge off and not do the exam because of this. You still have to have a go at the exam and get close to a pass. Alright, the exam is on 3rd of December. I'm allowing you 12 hours, starting at 10 AM, ending at 10 PM. I reckon the exam is going to have about 3 hours worth of work in it. You can spend your time however you like in that 12-hour period. You could do 1 hour, go and have a cup of coffee for an hour, come back, do another hour, go and have lunch, come back, do another hour, go and have afternoon tea, come back and do another hour if you need to do 4 hours work. I suspect most people will take between 3 or 4 hours total working time, but they can spread that 3 to 4 hours across the 12-hour period however they like. 60% of the exam is prac work, including all of those technologies. 40% is theory, and basically what that means is typing some answers. So if you've looked at the sample exam, you'll see that part of the theory is writing triggers. Triggers are a hard thing to do in an exam because you have to modify a database, and we don't want to fiddle with the database that we're using for the rest of the prac questions. And we don't want to have you building 2 databases in the exam. So what do you get in the exam? You get the exam paper, duh, with all the questions, all 12 of them. Since there are 12 questions, you could spend 1 hour on each question, and that would take up your 12-hour time period. You probably won't need to. You can look at the course website, you can look at the doco. I've got some summary documentation, but there are also links to the off-site Postgres manual, Python manual, and Psychopedia 2 manual. And of course, since you're working at home on your own machine, you can look anywhere you like on the web, except Chegg.com. And all of those other tutoring they call themselves, websites. Alright, how do you revise for the exam? Look at the lecture notes, mainly the slides. I didn't update the lecture notes much. Sometimes they have more details than the slides. Sometimes the presentation might not be quite as good as the slides. Then there's all the exercises. So there's the tute questions, the prac exercises, and of course the assignments. And there's the 5 books that we suggest. If you can grab a hold of one of them, that might help you. And then of course there's all the documentation. Now this is actually useful to make yourself familiar with all of these documentation, just in case you need to look up something in the exam. So you've got a vague idea of where it is, and say you've forgotten some command in Postgres and you want to look up what's the function for stripping spaces off a string or something like that. if you've got a vague idea where that is in the manual, you're not going to waste as much time as if you just go into the manual and you've never actually looked at it before. Alright, so what do we do? Assessment. Well, we need to work out how well you understand the content of the course. And in some sense, we're certifying you. We're saying, yes, this student has completed this course and they have a 90% understanding of the content. To give me a basis for assigning a mark like that, you need to demonstrate to me through the assignments, through the exam and so on, that you actually do understand stuff. If you can't demonstrate that you understand stuff, you don't pass the course. And every year I get people who clearly didn't do this, or at least they didn't do it in the exam, the assignments and so on, and they come up with reasons why I should pass them, despite the fact that this clearly didn't happen. And I've heard all of these over and over again over the years, most of which things that happen outside COMP3311 aren't my problem to fix. So if you fail 3311 and that prevents you from doing some later course, you should have passed 3311 is the obvious solution. Okay, so we assess you, but of course you get to assess us, and we've been bombarding you with spam about doing my experience. UNSW is obsessed with response rates, and they love every course to have 100% of students give some feedback on the course. Never happens, but they keep hassling us to try and get the response rate as high as possible. So if you've got 5 minutes to spare to give us some feedback on 3311, that would be extremely useful. Telling me good things, yeah, that's fine, and it strokes my ego, etc., etc. But the more important things is telling what we can improve so that next time we run this course, it'll run better than it did this time. And if we keep doing that, eventually 3311 will be perfect. Okay, so if you loved 3311 so much and now you're in love with databases, here's a bunch of courses that you might think about doing. I think they're all running next year. We finally got someone to teach big data. Actually, this description of big data isn't quite accurate. I mean, that's what you'd think big data was, but they're actually talking about more about analytics and things like that in that course. 9395, hey, that's a magnificent course. Runs in term 1 next year, taught by me. And there's these other courses as well. Okay, well, you know, this is the final lecture, so we get to espouse some homespun philosophy. And one thing, it's a bit late to tell you this now, but what you should have been doing during the term is learning stuff that you're going to remember, and not, let's do the assignment and then we can cram for the exam. You really need to remember this stuff, and particularly for the database course, you're likely to be dealing with databases quite a lot in your future career. So, you know, it's worth remembering stuff, or at the very least, remembering your way around the Postgres manual in case you get to use Postgres in your workplace. And if you happen to end up in a workplace that for some reason doesn't use Postgres and should, then it would be great if you became an advocate and managed to persuade them to use Postgres. I know that some former students have actually managed to achieve that in their workplaces. one very important thing that you can learn out of this course, and it's not specific to this course, but learning how to find answers by yourself. When you get to a workplace, you're not going to have a forum where the friendly lecturer will give you an answer. What you're going to find is that you are left to work things out yourself. So learning how to find things right now is a very useful skill, and hopefully something that you develop over your 3 or 4 years of study, or will develop. A lot of students seem to be obsessed with finding a single correct answer. There isn't one most of the time, and there are solutions that work but don't work very well, and there are solutions that work brilliantly and are maintainable, and so on. And of course, take pride in what you're producing. You're producing a document. A program is a document. Someone might eventually have to read it. God forbid, not just a tutor giving you a mark, but a co-worker who has to work out how your code actually works. So make sure that the code is understandable and not just a hack to do what's required to pass the unit test. Okay, and that's it. So normally at this point there's a huge, thunderous round of applause. We're not in lectures here to where that can happen, so c'est la vie. You can sit at home and go if you like, but I won't hear it, unfortunately. So good luck with the exams, good luck with studying for the exams, and good luck with whatever you choose to do in the future. Okay, thank you.